Thank you. Good afternoon, friends, ladies and gentlemen. Welcome to one of the middle of the day sessions by Accenture. As has already been pointed out, I've had the privilege to work with a lot of Indian utilities clients in the capacity of a consultant. We helped Reliance Delhi reduce their losses from 60% to 12% over last 11 years. Implemented RAPDRP Part A for Punjab State, and implementing now a smart grid pilot for Uttar Haryana in Panipat, along with Fuji Electric. Helped Rockefeller Foundation with a solar microgrid project for rural India. So quite a few of those success, failures, learnings, and lessons behind. However, I will start with a report that our international colleagues have recently presented or submitted at the World Economic Forum, wherein I will be quoting some of the secondary data which was researched out by a group of professionals comprising Accenture as well as several other organizations under the WEF initiative. And then towards the latter part of my presentation, I will try to dovetail this to the Indian utilities context as to what are the similarities and differences between some of the developed countries scenario and our scenario, what may apply or what may not apply. So this is the background as to why a World Economic Forum would be bothered about smart grids. They have conceptualized something called the fourth industrial revolution, which has one amongst many global challenge initiatives called Future of the Internet, of which digital transmission initiative was one of the areas of study, of which electricity industry was one of the sub-elements on which this particular focus group dedicated quite a bit of effort to come out with the report. So report is already in public domain. I'm just sharing and socializing the outcomes. What were the trends which stand in the backdrop of the electricity industry globally? Decarbonization, which means there's a pressure to move away from greenhouse gas emissions, move away from fossil fuels, and move to green energies, largely solar and wind. Decentralization, which means there's a lot of shift for people to generate and consume their own powers, or large industries or communities to develop their own micro renewable energy sources. Intelligent enterprise, which means machines are becoming smarter, software is getting embedded, machine-to-machine communication is becoming more prevalent. Big data, when combined with advanced analytics, is giving a lot of useful insights in the form of smart data, and cost of cloud computing is falling. And the fourth trend that was observed was customer centricity, which means instead of a mass market, we are looking at mass personalization of very, very innovative products and services. Consumer is able to interact and engage with the utility in multiple channels, phone, web, portal, call center, and so on. And electricity companies are looking to diversify beyond energy. So what is it beyond the electron? I will touch upon slightly later in the presentation. These four trends overall are fairly self-obvious, we all know, but if you just look at it from a perspective, these are distilling out into two broad shifts in the utilities industry paradigm. One is shift to renewables, which is coming from decarbonization and decentralization. And the other is focus on analytics-led business transformation, that if utilities have to therefore evolve and metamorphose in this revised scenario, how do they add on new capabilities to their existing capabilities of driving O&M, network, business, commercial, revenue, this, that, plus very, very strong focus on advanced analytics to derive some new age benefits. This gives rise to digital themes and initiatives which have been studied, observed, and concluded as part of this study. If I were to superimpose them on the energy value chain, the first digital theme is, and there are four of them, the first is asset lifecycle management. One of the most dominant outcomes that has probably come out from this study is the fact that one of the most immediate benefits out of advanced analytics, which is the topic of this particular session, lies in the area of predictive asset maintenance, failure prediction, reliability-centered maintenance, which all goes into enhancing the asset life and the asset performance. Related to that is the digital field worker, which means because distribution largely is a spread out area of operation, geographically speaking, and so many field workers are working at any point of time in a remote corner of your jurisdiction, you need to have connectivity and mobile support to optimize their productivity. And third is smart asset palling, which is largely to do with renewable, where to set up your renewable plants, where the solar or the wind generation forecast is likely to be optimum enough to justify that kind of investment and allocation of land to renewable instead of any other alternative. The second out of fourth digital theme is grid optimization and aggregation. I think this is the most well understood topic given the audience in this event. Energy aggregation platforms, which means in the generation and trading market part of the value chain, instead of the conventional large-scale generators, there's enough space for people like you and me to generate and sell and trade and consume our own power and to match our respective demand and supply mismatches using grid as the platform. Real-time supply and demand platforms, normally supply and demand would have meant generation and consumption. Now it means generation, storage, back charging, and consumption. And real-time network controls, which means you need to do load balancing to minimize technical losses, minimize outages, avoid voltage fluctuations. Connected interoperable devices. So why should the grid stop at the grid? The meter, if it is smart, is at the boundary or at the edge of the grid and the consumer premises. So if the utility gets access to get inside of the consumer premises, be it residential, commercial, industrial, agricultural, then there are a lot more value-added services which can be personalized consumer goods and services which the utility could either directly get involved into or would have strategic alliances to cross-market them. Integrated customer service. So obviously that starts from the distribution end of the value chain. One is storage. Electrical vehicle is one example of a storage. There could be several other examples. Energy management, digital customer model, and energy solution integration. What it means is that the customer will interact and engage with the utility and transact with the utility in a variety of ways, far more complex than the plain vanilla interaction, which is happening today, that we get a bill at the end of the month and we pay it. And the fourth is beyond the electron, which means the electrical distribution utility may be best placed to cross-offer some of the smart city related services, because this is the incumbent which already has all the database available of every individual household, premises, physical infrastructure, or organizations which are resident in a city. So instead of a telco or a bank or a government authority, maybe DISCOM is most well placed to start not from ground zero, but from a ground X and develop the data backbone of a smart city. Then obviously other players can use that data backbone as a platform. Second is energy efficiency services, which is in the industrial domain. So if smart city is more of civic and municipal domain, energy efficiency services are more in the industrial domain. And third and last is security and convenience products. You know, my car should talk to my AC, and when my car is 20 minutes away from my house, my AC should get switched on. All that kind of science fiction thing may be a reality in 10 years from now. Okay. Some of the detailing very quickly. So asset performance management will largely anchor around condition-based monitoring, failure prediction, and predictive maintenance. Digital field worker will largely anchor upon electronic work packages, which are, you know, instead of a logbook or a paper-based job sheet, the guy carries some kind of an iPad or a tablet or a smartphone and is able to, in real time, update all his records of what he's doing, where he went, what he met, what he couldn't do, how much material he consumed, where the consumer was not available, he has to make a site revisit. All of that can be recorded, updated, processed in a near real-time basis, and all the planning and scheduling can be optimized based on electronic workflows instead of paper-based workflows. Smart asset planning, predictive analytics, machine learning, robotics, and renewable generation forecasting. What is the value to be unlocked? You've got increased asset life, improved productivity by human workers, and optimized site selection for renewables. Yeah. The last one becomes important when you look at the scale. 60 gigawatt of ground-based utility scale solar, 75 gigawatt of wind. We need to be very sure where we are putting up, what we are putting up, and how will that power be scheduled. A marginal improvement in the operating efficiency of generation transformers or power lines will have exponential effect once scaled across the industry. That was one of the findings for this. I've talked about energy aggregation platforms, real-time supply and demand matching, and connected interoperated devices. One of the enablers for this is real-time pricing. If you really, really want to have not just TOU tariff in a very plain vanilla sense, summer, winter, peak, off-peak, but in a more dynamic manner, then real-time pricing would have to be enabled through some of these digital enablers. And that is where the true value can be unlocked from the mismatch of current demand and supply positions, especially given that storage will become an option, and given that a lot of us will become prosumers over the next 5 to 10 years. See, everybody talks about the cost of photovoltaic dropping. One would also need to remember that the cost of energy storage is also dropping dramatically. And the density of energy storage, which means the watt hours that you can pack into a certain liters of battery pack, is also dramatically improving. So if you put all the three together, I think energy storage is something which will become inevitable very, very soon. Before we know it, it will hit us. Value to be unlocked, transparency between utility and customer/citizen. If most of the utilities are government owned, then most of the customers are citizens as well. And that is where the political sensitivity around tariffs comes in. Now, even if the tariff cannot be reduced or whatever, that's fine. At least if there is a trust element between the citizen and the utility about what is determining the tariff. Where is it that it is getting built up, built down? How is it linked to coal price or crude price or photovoltaic prices, that itself will probably improve the public acceptance of whatever the tariff regimes are. Otherwise, people will always question that, we keep reading in the newspapers that price of solar is falling, price of my electricity is not falling. Price of crude is falling, price of my electricity is not falling. Losses are going down, price of my electricity are not falling. So not increasing will not be sufficient. You need to have that trust and transparency with the consumer at large as to why is it whatever it is, 5 rupees, 10 rupees, whatever it is. Non-energy services beyond the electron. So fully integrated citizen services such as transport, waste, and so on, for which DISCOM can provide the anchor platform to build all non-energy services. Enable industrial services such as power management, energy optimization, safety, lighting, etc. And security and convenience products for better lifestyle and ease of living. The value to be unlocked is data monetization. Take a look at e-commerce. Half the e-commerce companies are monetizing data because of the relationship basis that they are creating. And here we have a set of total 75 utilities across India, across 30 states, having database of about 250 million consumers. And we have not even started to monetize that data, right? So if you do that, you provide gateway to other services. Maybe you can rate a consumer on his credit worthiness and share that data with CIBIL and banks and NBFCs, and they'll be able to give him loans based on your assessment of their credit worthiness. Because you know every month how much bill they are paying or not paying. And if their electricity bill is say 100 rupees, maybe their income is 2,000 rupees. Those kind of ratios can easily be worked out if you put the right analytics in place, obviously subject to consumer consent. So some real life examples quoted from across the world where breakdowns have been eliminated. An example from Australia, Ausgrid deployed OIT solutions for field data collection across its distribution operations, covering X number of poles, stations, transformers, and what they witnessed, 72% improvement in productivity of human workers.
Shalabh, I'll have to tell you to wind up in 2 minutes.
2 minutes?
Yeah,
okay.
Will that be okay?
Sure. Another example from Germany, next Kraftwerk, Germany launched a virtual power plant in 2009 based on distributed generation capacity. In 2013, they managed 1 gigawatt of capacity from 2,400 installations and traded 2,500 MU of power, mostly from biogas, biomass, and combined heat and power plants. There are several examples. The report is full of these anecdotes. In Australia, people can sell back power, not only sell it back, but sell it in bids. You can invite bids for people buying your power. Nordic power market across 4 different countries. They've been able to synchronize their trade rules, regulations, everything. Why shouldn't we be able to do it across 30 states when we have one single grid? Business case from US, roughly $64 per meter per year of saving was estimated by a particular US utility. Half of which, 47%, comes from better asset management, and another few percent points from power quality, revenue protection in billing, outage, and fault intelligence. So what's the relevance and applicability to India? We'll look at similarities and differences. Similarities about what is commonly applicable, and differences. What is not applicable to us and what is specifically applicable to us may not be there in some of the developed world countries, relatively speaking. What may not be applicable to us, our cost of manpower is not very high, and job reduction or headcount reduction is not our priority. So the business levers have to come from somewhere else. What additional factors will apply more to us vis-a-vis our developed counterparts? The focus on theft and commercial losses, pushing customers to cashless payments as an outcome of a recent initiative by the government, and the scale of deployment, that ESL model that Sir was suggesting in the morning today. Take any number from US and America, add 2 zeros to it, and you come get a number for India. For that kind of economies of scale, why shouldn't the costs of, say, smart meter or any other product or services go down dramatically, much faster than the global trends? What is commonly applicable? Much more than what we think. Open access to separation of carriage and content is a matter of time. Net metering to full-scale prosumer and aggregator-based market is a matter of time. Electric vehicles, yes, today they are not there, but if you look at a 5 to 10 year horizon, they will probably be there before we know it. Falling prices of renewable plus storage plus computing is equal to a potent mix of explosive growth. CERC has already put penalties on variance between schedule and actual power generation and roll on from renewable, which effectively means you need to be very, very accurate in your forecasting, down to last 15 minutes on a day ahead basis. Focus on energy efficiency has been there through LED and PAT scheme. So the one in the circle may be slightly futuristic today, but it's a question of when, not if. Smart cities, easily understood that smart grids would be a key enabler of smart cities. So what is common is also substantial. It's not that we are very, very divergent from our developed counterparts. Parting note. We all are aware of this adage, gold in, gold out, garbage in, garbage out, where the left side refers to raw data, the black box refers to analytics as an engine, and the right side refers to the output of information. This is a more conventional paradigm, which we can call BC, before computing. AD, after digitalization, you can either have your business as usual analytics, which is the normal, mediocre kind of analytics that we are all used to, or you can have really, really advanced analytics as is being professed in this session. What would be the difference? If you put your smart meter and smart grid and all this big data onto a very, very conventional, lukewarm kind of analytics, what you will get is nothing. Lot of investment, no outcome to show, no ROI. Yeah. By contrast, even if you put a modest amount of investment in a very good advanced system of analytics, you will still get reasonably good results. With that, thank you.
Thank you, Shalabh.